So we make our powers chart so we can solve exponential equations with nice numbers. So the easy ones, right? The easy ones are just questions like this. 5 to the x equals 125. Because that's boom, right from your powers chart. What's it going to be? 3. That's an easy one. A medium one is when something comes from your powers chart, but it doesn't necessarily fall in the same place. So for example, I could have 9 to the x equals 27. So 27 isn't in my chart for 9s, right? But 9 and 27 are both in my chart for 3. So what I could do is I could rewrite these as powers of 3. 27 is 3 cubed. 9 is 3 squared. So I would still have an x out here. This is a medium one because you first had to recognize what column of our powers chart were both of those numbers in, and then write them as powers of 3. Then can you see if you simplify using your exponent laws, this side is 3 to the 2x, and this side is still 3 cubed. Does it make sense that these two things in the blue circle have to equal? In order for those things to be equal, the 2x has to equal the 3. And so once you get the bases the same, it just becomes, can you solve 2x equals 3? Divide both sides by 2. And x is equal to 3 halves. The hardest ones in these, without our calculator, involve using other exponent laws. For example, you have to recognize them in the same chart, and then you have to be able to use a whole bunch. Should I try and think of the hardest one I can think of right now? Okay, so let's say you had the square root of 32x plus 1 equals 16 to the 3x. Whew. Yeah, that's kind of a little bit nasty. X. So are either of those on the same powers chart? 2's. So we could write this one as the square root of 2 to the 5 to the x plus 1. Just so I don't have to be so small. What did I had 32 to the x plus 1 equals 16 to the 3x. So this one could be 2 to the, oops, 2 to the 5 to the x plus 1. And this side would be 2 to the 4 to the 3x. Okay? Are you okay with this side using our exponent laws being 2 to the 5x plus 5? Are you okay with this side being 2 to the 12x? Yes? What do you do with that square root? Exponent laws. You could square both sides. Or what? How do you write a square root? It's a half. So now I could write this as 2 to the 5x plus 5 to the half, and this is 2 to the 12x. This is a tough one. You asked for the hardest one I could think of without a calculator. This is a pretty good one. How do we do that half outside? What exponent law? That half would get multiplied by this, so we now would get and in solving these questions without our calculator, this is our first goal. Can we use our exponent laws to manipulate things so that we get the same base on both sides? Because once we get the same base on both sides, whatever's the exponent on this side has to equal the exponent on that side. And now you can just solve that question of what's inside those green circles. 5 over 2x plus 5 over 2 has to equal 12x. And you just have to solve this. I would probably get rid of my fractions by multiplying everything by 2. And I know some of you were probably guessing and checking at the beginning and figured out that x was 5/19 right away. But there it is algebraically. Because it was so obvious from the beginning question that it had to be 5/19, right? No. Did I make a mistake? I'm good? Okay. So this would be the hardest one, where we have a lot of exponent rules to deal with in order to get to this place here. But this is our strategy. In fact, if we go back to our first question, you technically could have done that strategy even with this first one. You just could see it so easily that you said x was 3 right away. But can you see in the first one that you could have written both sides with the same base? You can change 125 to be 5 cubed. And then what's in the circles has to be the same. So x has to be 3. But that one was so obvious you didn't have to do the work. But later on, with the medium one, 9 to the x equals 27, it wasn't so easy to see. And so you got 3 halves. And then with the last one, you really had to do some work. Yes?
Yeah, the last one you just did, how did you know that? Or do I always?
I just made sure that I chose things that were in the same column chart.
So if they're in the same column.
If they're in the same column chart, you can change things to the same base, and they'll work. Okay? When we look at what we started with, the very first question, this 2 to the x equals 11, that's not in the same powers chart. We have to develop some new math in order to figure that out. But today, we're worrying about things in the same powers chart. So when we get to example 1 here, do you want to try these two on your own first, now that we've done a couple examples, or do you want to do them together? Do them together? Okay. So for part A, are 4 and 256 in your same powers chart? So 256 is 4 to the what? Or do you want to do it in the 2s? You could choose either one. You're going to use the 4s. 256 is 4 to the power what? 4 to the power 4. We're very close right now to having both sides as the same base. But the problem is on the right side, our 4 is in our denominator. What exponent rule could you use to take that out of the denominator? Your negative exponent rule. And now you've succeeded in getting both sides to be the same base. Once that happens, the exponents have to be the same. And on this one, it means that x is equal to negative 4, and we're done. (27 and 9). Are they in the same powers chart somewhere? 3. So we'll change 27. And again, when you're changing something, put it in brackets and make sure you don't forget anything that was there before. Because the 3 cubed just replaces the 27. It doesn't replace the x. And on this side, 9 is 3 squared. And we still have the 2x minus 1 out here. So now we use our exponent rules. What do you do with a power to a power? You multiply. So this side will be 3 to the 3x. And this side, when I multiply that through, will be 4x minus 2. And we succeeded in getting both sides to be the same base. And once you have both sides with the same base, then these exponents have to equal each other. So 3x has to equal 4x minus 2. Move the 3x over. Move the 2 over. And x is equal to 2. Nice. So the questions, well, for these ones without a calculator, I mean, I showed you the one with the square root. That would probably be the hardest. Yeah, that's possible.